Yeah, hello, thank you. My name is Gerardo Santillan. We are from Finland, yes. We are very happy to be here today and we thank the Disk ecosystem for inviting us. Today is a day off in Finland, it's a holiday. We are very happy to be here in Norway. It's not a holiday here. Yeah, so are you ready, Hanno? Can I start? Yeah, okay. Again, my name is Gerardo Santillan. I'm a senior specialist at Semantum. I have here with me Hanno Niemisto. He's CTO of Semantum. We're gonna be presenting this workflow that we have. We are trying to tackle different, or most of the points that were put here as a challenge or whatever it is competition. It is not a competition, but it is a competition. So we wanted to show what we are doing here. And since yeah, we are new to this, we wanted just to introduce our company briefly. Uh, we come from Finland, from Helsinki, and we have been working mostly. We are a software development company. Many of us have different backgrounds: software developers, automation experts, simulation, modeling and simulation experts also. And we have different focus areas. We are good with simulation, but we are also doing a lot of these engineering automation solutions, which is what we will be showing now. And for these engineering automation solutions, we have this set of, it's a tool set that we call Model Broker. And the idea here is that we are automating the creation of different engineering assets. So we have plan design, we extract information from it, and then we can create different things that are used during the engineering or the operation. And one of these tools is, well, we have a set of tools that is tackling different things that were put now part of this challenge. So I would like just to briefly introduce them before going into the actual demo. First, we have Model Broker for diagrams. That's how we call it. The idea of this tool is that we are taking material as PDF, vectorized PDFs, and we are extracting data. We are digitizing that diagram. We can recognize text, connectivity, and also different elements, and we create a DXP file out of it. Sometimes some customers would want a DXP file, but for some others, even the CSV file is enough. So we are also creating that, and we are using PNIDs, but also logic diagrams is also possible. So that is one thing that we will be showing. Then for visualization, we are using this Model Broker DXP viewer. This is not really a CAD tool. We want to be clear with this. It's only a visualization tool that we are using for visually inspecting the resulting DXP that we have. So it's an internal tool that we are using, but still we wanted to show how this is working. And finally, this Model Broker for control, where we are taking the already existing DXP file, and then we are transforming it, dumping it into a database, and then we are querying it. We are trying to find different relations between different components and doing different things there. It's originally meant, it's called Model Broker for control because we want to create control application automatically from the information available in the PNID. But then again, because all the PNID is available on a database, we can do different things once we have it in that way. Right, so now into the demo. This is the workflow that we are gonna be following. First, we want to create from a PDF. That's a little disclaimer. We actually took the wrong file, maybe. We took one of the PDFs that we don't know if it's the right one, but you will see. We digitized it, we created DXP, and then we are doing three things. We are importing it into a CAD tool. In this case, it's AutoCAD Plan 3D. We're also visualizing it in our own DXP viewer, and then we are also using Model Broker for control for trying to find different relations and to trying to find, for example, control loops that are available in a PNID. So yeah, the first part of this demo is how we are digitizing this diagram. This is a diagram that was available for us, from you guys, that you were giving to us as a PDF. So we are now doing this with this tool that we call Model Broker DXP Viewer. If Hanno would like to show that. Of course, I have the videos in case everything goes wrong. This is DXP Viewer, so it's the spoiler. We want to see already. We want to see the. If you show Model Broker for diagrams. Right. So here you can see the tool. This is a tool that it's actually given to customers and they can use it. The idea here is that we have imported here already this PDF file. This is a vectorized PDF file that was given by you to us. And the idea here is that we are not gonna do this as a live configuration, but the idea here is that one can configure different symbols and then extract information. We can recognize symbols so that we can map them into the XP classes. We can also extract text and use regular expressions to then use them as attributes of the classes that we are finding. And then we are also recognizing connectivity using these connection points that are user defined. So that as a result, what we have here, if Hanu eventually now is doing the translation, what we have as a result is the XP file that has all the information about topology, all the information about attributes that are available from the diagram, and it's all represented either as a CSV table, in the case that someone would want that. Some EPCs would want that, for example, when they are doing procurement. But then of course, most of us would want to have the XP file where connectivity information is also available here. So here you can see Hanu is showing all the different symbols that are found after recognizing this diagram. Hanu, can you show now the attributes as the text there? It's a bit messy, but if we zoom, yeah, you can see there how, for example, the text that we are finding is then mapped as one of the some of the attributes of the specific element that we're finding. And then Hanu, if you show the connectivity, you were already showing it, but there it is. Also connectivity is automatically found. We can see there, for example, how tag names are connected to pipelines, or different indicators are also connected to the specific symbol as an indicator. We can see their connectivity between components and its nozzles, etc. All the flow direction is also found because we are using also, for example, inputs and outputs of different elements. So when we have the result in the XP file, it's also possible to get that information. Yeah, yeah, exactly. That's the connection, how it is working. Maybe we go forward, Hanu. That's the video, but you already saw the live video. The live demonstration, sorry. So yeah, in this tool, what we are able to do, what I told you, we can recognize the patterns, and we can use all the graphical primitives to try to recognize all the symbols. It's very customizable so that you can make this translation better. And even if there's variability in these symbols, you can still try to find as many symbols as possible. We can have text recognition, as I was showing, and also we have connectivity. And this connectivity is based on these connection points that are the user defined. Right. Now I would like to show the next part of this workflow, which is visualizing this into this XP viewer. If you want to show it, Hanu, the XP viewer. So this XP viewer is an internal tool that we were always using internally. It's redundant. Sorry? Yes, of course, we were selling it now, but the idea here is that we started using it for ourselves, but then we saw that many people that are using the XP files started also wanting to have something like this, and it's pretty cheap. You can take a look. It's really, we cannot disclose prices here or anything, but yeah. So you can see here what we see here is the XML created directly. The visualization created from the XML that we created with the other tool. You can see here how Hanu is browsing through different elements of the diagram. We can see here tag names. We can see different attributes that are taken also from the text that we are recognizing. Well, that's the original, but it was not the best. But then this is the one that we created using the tool. Using the tool, yeah, we got a little better results. Yeah, or way better. Or yeah, well, I want to be polite, right? But if you take a look, for example, to an inline component, we can also take a look how the different attributes in a pipeline are also part of this element. And then if you go to the connectivity view, Hanu, please, we can see also how connectivity is available here. So you can see the green lines are connections from the equipment to the nozzles, then blue lines are pipelines, and red lines are signal lines. In this case, the OPCs, we didn't configure them, but we can also navigate through different diagrams, so it is possible to go from one diagram to another. And we also have this hierarchical view at the right side of the screen where we can browse through different elements in this plant view that we get from the DXP file. But alright, I don't think there's anything else to show here in this. This is just a visualization tool. It's to visually inspect this DXP file that we have. It is very good to see it, but of course these files, when the diagram is very populated, it's better to use other tools that we also have for validating. And we have this rule-based validation on this model broker for diagrams that we don't have time to show it, but it is supposed to do that, to read the next DXP file and check, for example, elements that do not have a tag name or lack of connectivity between components, etc. So we can also have these validation tools in that case. Then the next part of this workflow is importing this into a CAD system. Now, Hanu, maybe you don't have the... This is not a live demo because that takes a little bit more time, but we have a video on how we are importing this. I can show it here. You can see on this screen, yeah? How we are importing this XP file that we are creating with Model Broker for diagrams into AutoCAD Plan 3D. AutoCAD is one of the different CAD systems that is heavily supporting this DXP. So we have experience with this. We also have, of course, experience with other CAD software. What we are using here is what Autodesk calls DXP Plan 3D plugin. So it's a way for mapping the corresponding symbols of a diagram into their own symbology that they are using. It's something that needs to be done once, but once it is configured correctly, it is possible to import diagrams following the same configuration. And here you can see how the diagram is imported as an intelligent diagram. So you can browse even through all the different components, and also we can check all the attributes that we find from the PNID that we digitize. Yes. Yeah. I think that was pretty simple and pretty fast, but the idea is there that you can import this DXP file into an intelligent CAD system. Then another part that we are tackling here is that was there in the challenge was to search, query, and find relations between different diagram elements. We do not have a live demo for this, but you can show the tool because it's also a little bit time consuming to show everything. But we do have, for example, here screenshots, and you will see that the application they're working. How we are able to, once we have the DXP file, we can import it as in a database, and then using this model broker for control, we are able to query different elements. We need to define first these elements and how we are going to be naming them, and how to which class it corresponds, and then we are able to just run different queries. That is very simple. It is something that, of course, can be done even with search texting, with searching the text. But then the main idea of this software is that we are able to find different relations between elements. So what Hanu is showing now is different control loops that we are able to find just by defining rules. Rules that can be seen on this screen. So that is the tool, and this is the configuration of the tool. So we would want to find these relations whenever we have a controller, a transmitter connected to a certain element. We're asking that tool to give us a table of these components so that we can then use this table and then create in the control application software the equivalent. So it is a way to create these stabilizing control loops defined on the PNID automatically. This tool supports right now some simulation systems and also some DCS systems. But the idea is simple, and I think many DCS are following the same idea, that these are defined as tables. So you can imagine that this can be also extended to other DCS systems. Yeah, we are using this tool not only for creating control application, but for data inspection and free-form text search. We can create these control applications using these typicals. We can also enrich information that we get the PNID and then import information from external data sources. And sometimes we also use it to validate the diagrams based on design rules. If we want to know that, for example, every actuated component or every class of actuated, every instance of actuated component in a diagram needs to be connected to something, and for some reason it is not, we can easily define the rule and then find any inconsistency in the material. Yeah, so that is what we did, just a summary. We have still 5 minutes, so I can be a little bit slower. That is what we did. We imported we created the diagram using this from a PDF. We created the DXP file. We showed how we visualized it, We also imported it into AutoCAD Plan 3D or into any CAD system, and that supports the XP. And we also did some query and some search of relations between diagram elements. Just as an idea, and more than idea, some of the use cases that we have had from our customers. Many of us, or many of our customers, would want, of course, the intelligent PNID from the available drawing, and that is most probably the most common case. But then again, when you have the XP file and you have this diagram in a machine-readable format, then many things can be done. We can, for example, dump this information into the information management system, into the asset management system. We can, for EPCs, they want lists for their procurement, so we can create these lists. Also, many customers want to link the 2D with the 3D to do this digital twin, this 3D digital twin, so it is possible to do that. It's also possible to enrich the information from the PNID using other data sources. EPCs want to reuse the existing design material, and just for any kind of plant renewal or control application renewal also, they would want to have their brownfield diagrams now digitized. Also, for creating process HMIs is also something important that control application vendors would want to create these HMIs, because they usually resemble very much the PNID structure. And also, control application vendors are able to create these PLC programs using the information from the PNIDs. We have been collaborating strongly with this with Yokogawa Electric from Japan. So we have had many cases with real projects. So yeah, we are very familiar with all the issues that and different things that for which customers are using the XP. And in general, the machine readable format of the diagram. But thank you. Hopefully we tackle most of the points that were here part of this challenge. Thank you very much.
Thank you so much, Semantum. You worked some kind of magic with the PNIDs there. Amazing. Okay, any comments from the technical committee?
I think you missed one of our meetings where we highly recommended not to use this PNID. And me and Tonja and the rest of the team had a long discussions on it, but it was very impressive.
Thank you. Yeah.
Yes. So thank you very much, guys. I'm impressed, and I see I'm at least ticking off most of the points on my evaluation.
Great.
Very good. Big applause to Semantum.
Thank you.